So what we're going to be talking about today is we're going to be talking about calculating percents of increase or decrease. Sometimes when we go to the store and we go to buy something, sometimes the price goes up or sometimes the price goes down. And one of the things that we're able to do using equations, just a simple equational procedure, is to be able to calculate what these percents of increase and decrease are. We can also determine markups and markdowns, and we're going to do a little bit of everything today in the class. All right, so the first thing I want to do is show you in a type of an example, right? In every one of these word problems that you have, okay? And remember, just as a reference, all of this stuff that's up here, slide, I sent it out to you as a PDF. You can pull it into Notability if you'd like, and you can overlay it with the notes that you want, okay? So right now what you have is you're going to see two numbers that are involved in your word problem. Every word problem here is going to be set up in two ways. You're either going to be presented with percents in your word problem and you're going to have to find out values, or you're going to get word problems like this that are going to give you the values and they're going to ask you to find a percent. So these are done two different ways, okay? And one of the types of things that you do is you have to determine whether or not and what is the percent of increase or decrease. So in every one of these word problems, the two numbers that you have, you always have a before number and then an after number. For instance, I give you a really simple example, right? You were going to the store, you saw a hoodie that you wanted to buy. It's $40. It's a Halloween themed hoodie. And then you didn't buy it before Halloween, but you go after Halloween and they have it on sale, 25% off. Okay? So obviously you're going to buy the hoodie. It's not going to be as expensive as it was before Halloween as it is after Halloween. So the cost of the hoodie, the before price was $40, and then what's going to happen is you're going to pay an after price, which in this case was lower. It was a sale, so it's a decrease. When your before number is bigger than your after number, this is an example of a decrease. So it would be starting at 320, and then it goes down to 280. Your job would be, what would be the percent of decrease? If your number went from small to large, you would end up having an increase there. To solve these, to determine what the percent of an increase or a decrease is, all you do is you're going to make a fraction. Now, the fraction we're going to make is going to be, sometimes proper, sometimes improper. And we need a numerator and we need a denominator. To get your numerator every single time, all you do, and that's the top of your fraction if you don't remember. To get your numerator, all you do is take your before number and your after number and subtract them. Take the difference between the two. So in this example right here, you have 320 minus 280. And that's going to come out to be 40. So 40 is my numerator. The bottom of your fraction, which we call the denominator, will always be your before number. So your top number is the difference between the before and after number. The bottom number is going to be the before number. So what's going to happen is it's going to look like this. So now I'm going to have a fraction that's 40 over 320. And the calculators are required for this unit, because anytime you're dealing with percents, you're going to be dealing with decimals. And the whole reason why we use decimals in the first place is because we're using calculators. All right? A lot of people don't realize that fractions were essentially created so that we didn't have to use calculators. Fractions make math basic and easier to do when decimals are involved. Fractions and decimals are the same. The majority of numbers that we use, you can write them as a decimal, you can write them as a fraction, and vice versa. But when you get problems that are decimals, you want to make sure all the time that you have a calculator handy. Now, the procedure is to determine what the percent of increase or decrease is. And remember, in this problem, this is a decrease because we went from a big number to a small number. What you essentially do is you take the numerator, which is 40, and you divide it by the denominator, which is 320. So numerator 40 divided by denominator, which is 320, because that's essentially what a fraction is telling you. It's telling you to divide. So when you do that, When you take 40 divided by 320, you get 0.125. And that, ladies and gentlemen, is the decimal value. What you then need to do is you need to make the decimal value into a percent by simply multiplying by 100. Any decimal that you have, to make this into the percent, you just got to multiply it by 100. So 0.125 will give us 12.5%. One of the other things I want to tell you in this unit is do not round unless the question says so. You don't want to make this 13. You want to keep this 12.5. And yes, percents can have decimals in it. Percents can be big. Percents can be really tiny and small. Okay? So when you get a number, if you think it's a shocking answer, you know, there's a strong probability you could be right on this, okay? So this is the technique that we use when you're given two numbers in a problem, a before number and an after number, and they're asking you for a percent increase or decrease. You technically do the same procedure whether your number goes up or it goes down, okay? The other thing that you're going to have to do in this unit is sometimes you're going to have to take a percent right here, and you're going to have to make that percent a decimal. So real simple, if I have to take a decimal to make it a percent and multiply it by 100, then you can go backwards in math. Remember, if you could take 2 steps forward, everybody knows you can take 2 steps backwards. If you start with something and you multiply it by 100, if you want to get what you started with in the first place, you go the opposite. And the opposite of multiplying by 100 is dividing by 100. So if you guys have a percent and you want to make it into a decimal, all you have to do now is divide that guy by 100. It is that basic to do. The reason why I say this is because now my decimal value is going to be your multiplier. In mathematics, you never multiply by percents. In science, in social studies, anytime you have to do any type of math whatsoever with percents, the first thing you have to do is take your percent and make it into a decimal. You multiply and divide by decimals. You never multiply and divide by percents. If you do, it's surely the quickest way to miss a question. So every percent that you ever have in a math problem, eventually what needs to happen is that percent needs to be converted into a decimal. So just want to make that very clear for everybody before we move on any further. So here's another example, very similar to what we just talked about. Except this time when you're looking at the example, the before and the after, you clearly see that the before is less than the after. So this is an example of an increase. So to do the increase, you do it basically the same way. You build a fraction. The top of the fraction is the difference between these two. 25 take away 15 is going to give you 10. The bottom of the fraction is always going to be the before number, always, whether it's an increase or a decrease. So now when you build this fraction, what you're going to see is you're going to see 10 over 15. And then when you take your calculator and do 10 divided by 15, you get 0.6 repeated. And this comes out to be 66.6 repeated percent. I also want to take a moment to talk about bar notation. Everybody notices right now that there is a bar above the 6. If you've never seen this before, this means when you use this and you did this on your calculator, when you took the 10 divided by 15, you didn't get 0.6 on your calculator. You got 0.66666, and it kept repeating over and over again. And then some of your calculators might show 7 at the end, and the only reason you see that is because it's rounding. But this is called a repeater. And what happens is when you have, yes.
I have a question.
Go ahead.
Why did you put 10 over 15?
You have to make a fraction when you do the before and the after, okay? So just like we did in the last one, okay? Just like we did in that last example, you have to make a before and an after. They give it to you in the problem. We had a before, which was 15. Our after was 25. So the fraction that we have to make has to work this way every time. The top number of your fraction is the difference between the before and the after number. So the 10 comes about because we took 25 minus 15. The bottom of your fraction will always be the before number. Whatever the before number is, that's the bottom. And once you have your fraction, you want to make that fraction then into a percent.
So when the after is bigger, do we just subtract from the after?
You always take the bigger number minus the smaller number, no matter what. So if the before number is bigger, like the last example, it was bigger minus smaller. The good part about this, there are no negatives. When you're talking about money, you're talking about business, you're talking about sales. When was the last time you walked into the store and you bought something and it was a negative $3? All right? So you don't have to worry about any of that because that's the unit that we're going into right now. All right, you get nice, fluffy, whole values. Yeah, there's some decimals from time to time, especially it's money and change, because we're going to be talking about like tax and tips and all these other things that, you know, that we leave in restaurants and we go out and we buy things. But in this unit, you're not going to have to worry about negatives because the negatives don't make any sense with what we're trying to do. Okay? Does that make sense?
Yes.
I hope it does. Good, 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 good. All right, so this is what we got. So I go back and I talk about this this bar notation thing, right? So you see this bar above this. So what happens is numbers tend to repeat sometimes. Not all the time, but sometimes they do repeat. Sometimes one number repeats. Sometimes two numbers repeat. Sometimes you can see multiple numbers that repeat. You want to try something out? Take your calculator for a second. I want you to do something. I want you to notice something. A lot of people will see this and they'll say, that's not a repeater, Mr. Besh, until they pay attention to it. And then they're like, yeah. Anytime you take a number and you basically divide it by a lot of odd numbers, not every odd number, but a lot of odd numbers, you get repeaters. If you take your calculator right now and do 1 divided by 13, look at this number. Take 1 divided by 13. People will look at it and say, Mr. Besh, that's not repeating, until they actually pay attention to it. And they say, oh, yes, that is definitely a repeater number. If you take your calculator out and do 1 divided by 13, you'll see that it says 0.076923. Then it repeats the series all over again. So some of these numbers, you have 1 repeating value. Some you have 2. Sometimes you have 3. I've seen numbers that were like 0.13131313. This is an example where now the bar would go over the 0, the 7, the 6, the 9, the 2, and the 3. Your bar goes over as many of the values that tend to repeat in the pattern, and once the pattern starts over again, you no longer have to write your values. In the case to the example that's up here on the board, it obviously repeated with the 6s. So now, once I get the decimal, notice the decimal value, 0.6 down here. Notice my decimal value only had 1 number in a bar, because that's where it started to repeat. Now, when you take the decimal and you multiply it by 100 on your calculator, you're going to get 66.6. Notice the bar only goes after the decimal place, not before the decimal place. So when we multiply this guy by 100, you're going to get 66 point. And now this is where they start to repeat. So that's why that has that bar right there. Okay. Now, obviously, I want you to realize this. You see this from time to time, specific tests. It's impossible to write bar notation using computer programs. You're not going to have to do this on Socrative. You're not going to see that, okay? If you had a problem like this that was a repeater on a computer program, watch the directions, because it might say round to the 10th spot, round to the 100th spot, okay? But you won't have to ever do bar notation on something like that because of the limitations of the technology. So, give you some examples here. So here's the first of the examples. These are the types of problems that you have. You know, here's how we use it and apply this in reality, right? So you go to the store and you're going to buy something. You see this all the time. TVs. You look at it and say, okay, I planned on spending $1,500 for this gigantic TV. And when I went to the store, I was shocked because this TV is now on sale. and I want to figure out specifically what percent off that I got on the sale. So now I know the TV was going to cost me $1,500, but yet when they rang it up at the checkout, it was only $1,200. So this is an example from what we just did a second ago of how we can determine what that percent off would actually be. So now the before number was the price of the TV on what it was going to cost you, which is $1,500. The after number is going to be what you actually paid for the TV, which is $1,200. So then you apply our technique. So now clearly it went down, so it's a decrease. And then when we set up our fraction like we do, we take the difference between the two numbers. So 1,500 minus 1,200 is 300. That's why it is the top number of my fraction. The bottom of my fraction is 1,500 because that was the before price. And then all I have to do is make it into a percent. When you have a fraction, to make it into a percent, you first make it into a decimal. You take the top of the fraction divided by the bottom. 300 divided by 1,500 is 0.2. And once you get your decimal, you make that into a percent by multiplying it by 100. It's exactly right. That'll work as well. Absolutely. What you're going to see next when we go through a few more example problems is you're going to see exactly what you just did, just another way. I usually do that technique and show people when you have a percent in the problem and how you have to calculate one of the either before or after numbers. So yes, that's a very good strategy. That will work 100% of the time. Okay. All right. So any questions so far with these two examples that we did, right? So that was essentially, here's question number 2. Here's the second one, and this is the last one that you have on this PDF, and then I'm going to add a few more to our mix. So this is true, this happens. Sometimes, not all the time, do you go to the store and you buy things and they're on sale. Sometimes there are markups, all right? Sometimes there are markups. I saw a markup firsthand this last year. You look down in Florida and you look at water, right? You go to Sam's Club or Costco, you buy a case of water, it's like $4 or $5, right? Hurricane season comes, everybody hoards, everybody stocks up on stuff. You'd go down there and you'd see like little convenience stores selling a case of water for $20. And I'm not kidding, just because there were so few of it around. You also see this right here. People are hit pretty hard on Valentine's Day for flowers. You see, if you go and you buy flowers any day of the week, any time of the year, if I went February 1st and I get a bouquet of roses, say there's 18 roses in the bouquet, that florist is usually charging me about $30. Candy works around the same way around this time of year. Then Valentine's Day hits, the next thing you do, you go and you try to get those same roses, and now they're charging you $75 and not 30, because they know everybody's going to be buying them that day. So this is an example where now you got a before number, which was 30, and you got an after number, which is 75. So this isn't a decrease. This is clearly an increase. So now you go through and you use the same exact method. You take the difference between the two. 75 minus 30 gives us 45, so that becomes the top number of your fraction. The bottom of your fraction is always the before number. And now you make this into a decimal by taking the numerator, the top, divided by the bottom, so 45 divided by 30, and that gives us 1.5. And then you make that into a percent by multiplying it by 100. Now, something here that I want you to note. Percents can be more than 100, okay? Especially in the business field. It happens all the time. This is how people make money in small business and in large business. You see, how a business basically works simplified is a business goes out and buys a bunch of a certain product, and the more they buy of the product, they actually get a lower price, And then what they do is they take the product and they mark it up. So they sell 1 or 2 to you when they might be buying 100 or 1,000, and they sell it for a profit. And that profit is going to be a percent. Sometimes that percent's a lot higher than you think. All right. Sometimes that percent could be in the thousands, the 10,000s, the 100,000s. You do realize the 2 biggest things that are markups that exist in our world right now are purses and tennis shoes. Purses and tennis shoes. The average pair of tennis shoes these days sells for over $100 sometimes, yet they probably cost about $3 or $4 to make. Same thing with purses. Purses work the same way. They probably cost a handful of dollars to make, and then all of a sudden they're sold for hundreds of dollars, especially a lot of the designer stuff that you have. What they do is these are markups. This is how they determine these things. But no matter if you buy something that's expensive or you buy something that's cheap, everything that you buy in a store was marked up because the store has to make a profit. And this is how they determine them. Just a couple facts I want to bring you about fractions. If you have a fraction where the top number and bottom number are the same, that's always 100%. Anytime you have a fraction where the top and bottom are the same, that's always 100%. Because that fraction reduces down to 1, and 1 is the decimal, and 1 is a decimal means 100%. Anytime your top number is smaller than the bottom, your percent will be less than 100. Anytime your fraction has a number on top that's bigger than the bottom, it'll always be greater than 100. So those are 3 little facts that are associated each and every time we deal with the fractions. Okay. So now, some other applications and some other things that you could see from time to time when we talk about percents. So look at this example right here, and this one right here, I have just a few just to show you how they come into play. So this first one right here, we got Cassidy buying the pair of shoes. Let's go down to this one. Let's scroll up. Dominic, I like this one best because this one, I haven't done this one exactly for you, so I want to make sure that we're all on the same page. So now, Dominic has 16-ounce energy drink, and that this happens all the time in school. This is true. People will bring in drinks. They will bring them into their lockers, and then they will take their drink and they'll put them in the top shelf of their locker. And they know they're not allowed to do this. Like today, you got your water bottles and there's a cap on them in case you drop it, it doesn't spill all over the place. But people will still do it. They won't follow the rules. And they bring these things in and they put them on the top shelf of their locker. And every single year, there's at least 3 or 4 people that by some chance they fumble, they bump it, they drop it, it falls. Either glass breaks, because what's real popular is those Starbucks glass bottled coffees they get in the morning. Or you always see energy drinks. And energy drinks make the hallway all yucky and sticky. They get all dirty from people walking through it. Then your feet squeak all day long because you're walking through it. It takes forever to clean up. Well, that's where we get this problem, because this is essentially what happens. This person ends up taking an energy drink, a big can, 16-ounce can, and then he drops the can onto the ground. Luckily for him, he picks it up because not everything falls out of the can. This is an example where 18% is gone. So this is what I was talking about in a second about how we're going to use those percents. All right? When you have a percent problem like this, and you want to know how many ounces of liquid are still left in that can, this is how you do the problem. The first thing that you do when you have a problem such as this, and they give you a percent in the problem, the first step you do is you always start every one of these with 100%. If they give you a percent in a problem, this is where we always start. We always start with that 100%. Then it may take you once, twice, 3 times to read that question. But now what you want to do is you want to read that question and decide, are we adding in this problem or are we subtracting? Is liquid going into the can or is liquid going out of the can? Because now They ain't going to tell you whether you're subtracting or adding. They're going to put it in terms of just an example, and you are going to have to be the one that looks at it and says, oh, this is subtracting. We are losing liquid from the can. Just like the pool example, where we were losing liquid from the pool when we were draining it, okay? If we were filling the pool, we'd be adding to it, okay? So now what you simply do is you start with 100%. You take the percent that's in the problem. After you decided whether you add or subtract it, you do that next. So this is going to take us to 82% here because we lost 18%. And now, like I explained to you, we don't ever use our percents when we're doing our math. We make the percents into decimals. So now what you have to do now is after you take that percent away from 100, make your percent into a decimal by dividing it by 100. And when you divide that by 100, you get 0.82. This, ladies and gentlemen, becomes your multiplier. 0.82 is your multiplier in which you multiply your value by to determine exactly what's less. When you multiply by a decimal that's less than 1, your value is always going to decrease. Your answer is always going to be less. When you multiply by a decimal value that's greater than 1, your answer will always be more. So if you're losing something, you know, you can think about it like it's going to make sense. If I'm losing liquid from my can and there were 16 ounces in the can to start with, there better be less than 16 ounces when I'm finished. All right. It wouldn't make sense to say Dominic dropped his can, lost 18% of his beverage, picked it up, and now there's 20 ounces in the can. Okay. It doesn't make any sense. So now you want to make sure when you're doing your answers and you get an answer that your answer actually makes sense. So then with your calculator, all you would do is take 0.82, multiply that by the ounces that was in the can in the first place. And when you multiply these together, you get 13.12. And that is how much liquid, that is how many ounces that you have left in a can. Note I didn't round this. Note I kept the decimals after what my calculator told me to. The only time you ever want to round a question is when the directions specifically say to round. A lot of people have problems with that in mathematics, okay? You only are technically supposed to round in math when you get repeaters. When your calculator has a bunch of decimals that make it real hard for you to write down an answer or answer something, like you keep getting repeating decimals or non-repeating decimals, like you just keep getting something that extends forever and ever, or you get like 6 or 7 decimals in an answer, that's the time where you round. When your calculator terminates like this does, when your calculator ends with 1 number after the decimal or 2 or 3, you write down that entire answer unless the directions specify otherwise. Okay? Because that's technically the correct procedure to involve. So this was the first of our examples that we had. Okay? Now, I got a few more of these, but here's the deal. I'm saving them for Monday and Tuesday just to show you. There's a couple that have examples of like what happens when you have multiple increases, multiple decreases, an increase or a decrease. But to be flat out honest with you, everything I showed you today, this is essentially what our first quiz on this unit is going to look like. This is what we're going to have to be able to do. We're going to be taking these word problems and we're going to have to apply everything that I showed you today to answer our questions. All right? So there's nothing to submit tonight. There's no homework tonight. If you need to go back over and you need to take a look at your notes, that's what I'd like you to do over the weekend. But other than that, this is basically it. Okay? So ladies and gentlemen, that is the lesson. If you need anything, do not hesitate. Just ask me. But that's basically it for today.